Hey guys, welcome back. We're here to talk about Pareto charts and box and whisker plot charts. So I'm going to walk you through really quick how to make these two charts. They're very effective if you want to analyze cohorts of measures, distribution. If you want to look at maybe isolating where you can have the most impact on your strategic kind of decisions that you want to make based on your data. So first thing we're going to do is we're going to make Pareto chart, and then I'm going to walk you through how we're making that, and then we're going to make a box plot chart or a box and whisker chart, and I'll walk you through that as well. So what you see on the screen is a Tableau worksheet. For today's lesson, I'm going to be using Boston Marathon results data sets. I found a data set online that gave me the list of the 2019 Boston Marathon results, a list of 20,000 or so runners, their times, their official times, their country of origin, their gender, age. So we're going to use all those different dimensions to kind of play around with the data and create a Pareto chart and a box and whisker plot chart. So first thing first, let's go to the sheet. First thing I want to do is I'll look at the data myself. So let's look at the actual view data option of the results, just to get a feel of what we have to work with. In the data set I got, there was a lot of nulls. It looks like they wanted to track um, times at certain intervals of the marathon. Again, I got this online, so it may very well be a condensed version of the data set. But for what we're trying to do today, we have the necessary components that we need. So we have age. Notice I created a bin based on 5 years, so we're going to use later. We have other stuff too, like the city they're from, the country citizenship, the country of origin, the display name, so basically their name, what division rank they were at, their gender, the result by gender, their place overall, their time based on seconds. I made a bin out of that, you could tell, but here's the seconds. And then their finish time, which is basically a calculation I made based on the official time that they got here. So I kind of converted this, taking away the date part, and just did a time part, and um, converted this time to a finish time at the hours aggregation level. So first things first, let me show you that calculation on the hours, the finish time hours. So I basically just took the seconds. I didn't want to mess with the time part, so I basically just took the seconds and did an average of 3,600 to get a level at the hour level of what the finish time is. So for the most part, it kind of coincides to what the finish time is. There is a way to take your official time here, which from the data set format is a date time format, and then strip out the date, only have the time and whatnot. But I didn't want to go through the hassle of taking the date out, looking at only the time, taking out uh, the at meridian, post meridian, AM PM stuff, and having an official time. So I just went with the seconds since it was already at a number format. Okay, so let's go ahead and start by creating the Pareto chart. First thing first, I will bring in, let's bring in the finish time up here to columns. And then I'm going to bring in um, the number of runners. So what I'll use for this is I'll use display name, since every name is different. I'll just do a count. I'll bring in the rows, do a count here. I'm going to change this to, let me see. Okay. Actually, instead of the finish time, let's bring in the official time here. There we go. And I'll go to exact date. There we go. All right. So basically, this is at the time that runners finished the 26-mile marathon in Boston. don't mind the AM for now. We're just gonna do this to create the Pareto chart. So this is basically listing um, when runners finish and at what time. So you can see that based on their chips, on their bibs, the most number of runners finished at the same time was 13 runners. But spread it across what 2 to 7 hours, 8 hours. The last runner ended at a marathon of 7 hours, 43 minutes, and 48 seconds, which I myself would take even at that point. I think the longest I've actually ran is 10 miles in a race, and that took me 2 hours. So um, that'd be awesome. I would take that time just to finish a marathon. Would be awesome. Okay, so you have your bar chart. Most Pareto charts, just to note, would want you to take a sort of this really quick and sort it by finish time. Since we're looking at continuous measures here and we're looking at individual runners, I'm gonna keep it this way because I'd like to still have kind of a context or a view of how runners finished in terms of distribution. Okay, so now what we're gonna do is we're gonna take the same display name here. We're gonna create a new count, but this time we're going to make this into a cumulative total. We're going to change this to a line. Change this to a quick tab calculation of a running total. So now we have a cumulative total. As you elapse in time, you're going to get to 100% here. So, and we're also going to change this. If you go to edit table calc, add a secondary calculation, and do a percent of total, you'll now have that represented as a percent of total. So notice how you see that 100% on the tooltip. That's basically saying that when the last runner crossed in 7 hours and 43 minutes, 100% of the total runners have finished the race. All right. So now all we're going to do here is do a dual access. Okay. And then I don't like how it kind of does this. Obviously, the you can notice how this starts at 0, this doesn't start at 0. All right, so basically what I did here, I basically created fixed ends and fixed starts. I fixed this at 1 and then fixed started based on, it was at 14 based on the data set size. And I fixed start this at 0 to 100%. So now we have a pretty slick Pareto chart. This kind of tells me, at what point did, 80% of the runners finish, 90%, whatnot. Let's say I wanted to create a reference line so I can kind of go back and forth by that reference line. Let's say I wanted to do, we'll create a quick parameter and we'll call this real quick ref line. And then we'll create this as current value. For now, we'll do 0.8. Okay. And then we'll go back here, edit, create a reference line. We'll select the parameter ref line. Label, we'll put the value. All right, so there's that. If I show the parameter, I can change the percentages to actually move based on what I'm putting. So let's put 75%. So notice that when these lines intersect, that's when you have 75% of runners. So at the 4 hour, 19-minute mark, 75% of the runners had finished. Okay. And let's say we want to do the elite runners. So let's say 10%. 3 hours. Pretty respectable time for a marathon. 3 hours is pretty intense. So you can kind of play around with this reference line. So that is your Pareto chart. Quick and dirty. Gives you a reference of percentage of total of your data set size versus distribution. Other use case scenarios, let's say for instance, we're looking at sales, right? You have a sales by category, and you wanted to look at sales represented by a bar chart for each category, and then total percentage of sales over a given period of time. Let's say a year, right? In that situation, you would have the bar chart for sales for each category. Then you would do a descending sort of the category by sales. Then at that point, you can actually use the 80% feature and say, all right, at 80% of sales, 85% of sales is at this point, that's representative of all these sales by category. So the basic strategy here in the Pareto chart is for 80% of sales, it's represented by this much of categories. So uh, the creator of the Pareto chart, his contention was if you concentrate on um, this percentage of cohorts, it'll impact 80% of the total output. So, for instance, his rule of thumb was by only concentrating on 20% of the actual categories of sales, you'll actually impact and affect 80% of the total sales because his contention was that the largest impact or value of 80% of the total production is basically spurred or leveraged by 20% of the actual parts. So, it makes sense if you're looking at it from a sales perspective. Say you have a manufacturing process, you're looking at total sales. 20% of the models of a manufactured output represents 80% of the total sales of the company. So, your hot sellers, your hot items. If you basically concentrate on those parts that represent the large portion of sales, then you'll in fact get to the root of what's causing the downward trend in your sales, or continue the upward trend on your sales. So that's the Pareto chart. Let's go ahead and take a look at the box and whisker plot. So what I'm going to do is first show you um, the one I created offhand before I started recording. This is looking at it by gender. This is looking at it by average number of seconds. So what we're going to do here is we're going to separate runners by gender and then look at the distribution of when they finish the marathon. Okay? So let's go to a clear sheet. Let's bring in seconds here, up here. Under columns, we'll change that to average since we're going to bring in a distribution of runners. Let's bring in the gender of runners here. There's your chart. Let's go to the show me option. I want to change this to a box and whisker plot. There's that. I'll bring back the gender here, there, and then let's bring in the actual runner marks. So for this, I'll actually bring the display name here, and I'll do a count. Okay. Let's see. And then change this back to, yeah. Okay. There's that. If I bring my gender back up here, size. Okay. I'm going to go back to my finished one, go to my cheat sheet really quick. Okay, there it is. The seconds bin. That's why I created that. Bring in my second bins under detail. There we go. I'm going to make this entire view. Cool. So notice how I have kind of a quick representation of a distribution of runners. Doesn't really say much. Can't really see anything either. So I'm going to mess with the sizes a bit. Now we're really starting to see things pop. I can actually edit the axis as well and take away the 0. So notice how As this kind of object gets bigger, that means that there's more runners on average finishing the race at that time. So really, really cool way to just show distribution of runners. I'll change the background just to kind of show you, and I'll change the color just to make it pop. All right, cool. So notice how you can actually see a quick distribution and how it's compared by gender. Now let's say, for instance, I want to do by country. Take gender off. There. Detail. Standard view. Now you have a really, really busy, but you can see that it's now doing the same distribution by all runners and their country of origin. Okay? And you can see our ballers, Kenya, Ethiopia, are still finishing first. And then the most represented country, obviously, United States. But let me go back to gender. There we go. So that's your box and whisker plot chart by gender. This is showing each set of runners by age bin, by seconds bin, I'm sorry. So you can kind of get a feel of when they finish, those groups of runners. It's sized by count of runners. So obviously the smallest one would be here because those are groups of runners that aren't as, there aren't a lot of runners finishing at that time because there's only single runners finishing. And then you have your groups coming in bulk. And then the box and whisker, you have some extra statistics there. Your lower whisker at the 8,611 second mark. That's when the first female runners finish the race. Then you have your kind of your ranges. The lower hinge at the 12,000 second mark. The median at the 16,000 second mark, and then the upper whisker, upper hinge, upper whisker. So you get some additional statistics there. Notice how for the men, the medium 16,498, women 16,494. So kind of similar, but then as you look at the outliers of the box and whisker, then you'll see some separation. So for the lower whisker, 8,611. For the men, 7,732. So then that's when you start seeing the separation for running for at the gender level is at those whisker edges. But then for the most part, the median it's fairly close to each other as you get more and more of a sample size. So real quick, box and whisker, just to show you kind of how distribution works, utilizing some Boston Marathon results data set that I got online. Now I'm going to show you really quick. I create some other charts, made a quick dashboard for you guys. I took the let's see, I took some additional stuff. I took an image online of the Boston Marathon Athletic Association 2019. There's my box and whisker right there by gender. There's my Pareto chart. I did one for age bin to get a sense of finishers, their finish times by age bin. I also found a shapefile online for the Boston Marathon, and I just added that to a map, put that there just to give you reference of the actual route. And I did a map as well of finish time for each country being represented. So if you hover over the United States, you can see that there was about 20,000 runners with an average finish time of close to 4 hours. And if you go to our ballers, Kenya, 16 runners represented in Kenya, average time of just under 3 hours. Ethiopia, average time of 2.5 hours for 5 runners. So it gives you a real quick sense of the representation across the globe of runners in the Boston Marathon. But for the most part, there are benefits to the Pareto chart, getting a sense of utilization or how much production over a given period of time. So, for instance, you can kind of glide along this line chart of the cumulative percentage of total, and then get a sense of how many runners represent that finished percentage. And then, of course, you have your distribution of the run finishers, your kind of representation in the bar chart of finished times by age, and then a really cool box and whisker plot chart by gender, and then the distribution of the runners there based on average seconds. So, really hope that you enjoyed this kind of tutorial real quick of how to create a Pareto chart, box and whisker plot chart. Let me know what y'all think. Check out my dashboard I created here on my Tableau public profile. Check out my blog. Send me any questions you want on LinkedIn. And I want to see your kind of methods, your Pareto charts you've created, your box and whisker plot charts. And we'll see you next time. Take care.